Okay.
All right, hello and welcome. We are Group 10, and this is the Homeless Helper. My name is Zachary Sherm, and I'm the project manager. Our Scrum Master is Kathleen Tiley, and our development team members are Thor Johansson and Benjamin Weiss. The problem we aim to solve is that homeless persons are often not familiar with resources in an area. Sometimes this is because they are newly homeless or they have moved to a new city. These people need an easy way to find resources on where to sleep, eat, get clothing, transportation, and healthcare. The other half of the problem is that there are many people that interact with the homeless on a regular basis who need easy to print and filter, up-to-date, locally relevant resources for the homeless. Currently, some places, such as emergency rooms, have lists made by a social worker at a hospital, but not everywhere is lucky enough to have a social worker. Further, these lists are not updated frequently and often have out-of-date information. Our solution is the Homeless Helper. It is a web application that uses geolocation to provide local, up-to-date, curated resources for the homeless. The web application will have several notable features. The first is geolocation use. When the user opens the app, they are immediately presented with local information, or can input a custom zip code if they prefer. It will be mobile friendly, as many homeless do have devices that can use Wi-Fi for easy access to information on the go. The resources will be easily filterable, as not all resources are for everyone. For example, some are for women or children only, and some folks might have religious preferences. There will be Google Maps integration, which allows easy visualization of resource locations and for turn-by-turn instructions that are able to be printed. There will be easy printing of filtered local lists that can be printed by the professionals or volunteers who interact with the homeless regularly and for those without smart devices. And finally, homeless users can leave reviews for resources to help guide others in their decision of which resources to utilize, such as which are the safest or most reliable, or who has the best food. How will we get this data? The idea is for this to be a nationwide application or beyond, and that is a lot of data we don't currently have. So we will crowdsource it with local area champions. These will likely be social workers, and they are a great choice, as at least one person in this category is usually very knowledgeable about local resources. Their responsibilities will include maintaining an up-to-date database of all local resources for the homeless. Theirs will have a high level of detail, including genders or ages allowed and operation hours. They will also have to approve or deny individual resources to manage their own database entry. For example, the soup kitchen can update their hours. And they will also have to approve or deny resource champion applications for unclaimed regions. And with that, I'll turn it over to Ben.
Thanks, Zachary. So my name is Benjamin Weiss, and I'll be giving a brief overview of the architecture and design of our application. We broke down the architecture of our application into a number of different categories. The first is software. So the software components of our application consist of using the hybrid client server / MVC model. We felt that our application does not meet the requirements of either the client server or the MVC model strictly, and that a hybrid model made more sense since we're using the React.js front-end user interface framework. We're also going to be using the MERN stack, which consists of MongoDB as the backend database, Express.js and Node.js as the server and backend, and React.js as the front-end user interface framework. Our system is broken down into a number of components, namely the web browser, the user interface, account management, database interactions, as well as the database. Our data will be stored in a non-relational centralized database or a NoSQL database, which is why we chose to go with MongoDB, which is one of those kinds of databases. Additionally, we will also be interfacing with external APIs, such as the Google Maps API, to collect location data and to provide maps. The data in our application is user-driven, so all of the additions and modifications of data are being performed by community moderators. A little bit more detail on our hybrid model. As you can see with the client-server model, we have a centralized server that serves content to individual users' devices. Whereas in the MVC, which is short for Model View Controller model, you have this model which updates the view that the user sees based on input from the controller. The React framework does not fit nicely into either of these models. So our model is going to be more of a hybrid, where React is more of the MVC side of things, and the rest of our application will be more client server. Next slide, please. A little bit more about the architecture. So The subcategories of the components that we broke our application down into is the user interface, which will be in charge of displaying the resources to the users, allow the users to sort and filter the resources, as well as allow the users to access a database modification interface that will allow them to add or remove content. Another kind of functionality we like to provide to our users is account management. So certain approved accounts will be able to approve and deny requests by users for access. Users will be able to create and delete accounts. Users will be able to flag accounts that may be abusing our platform, and administrators and moderators will be able to verify the details of any account. Lastly, since our data in our application is going to be provided by the users, we need to define the functionality of the database and its interactions with our users. So we would like to allow our users to query our database, fetch information from our database, make additions and modifications to the data, and we would like administrators and moderators to be able to set the access privileges and modify the access privileges of any account. Next slide, please. Here's our system context model detailing the interaction of all the different components of our application and how they relate to the website. As you can see on the left-hand side, we have the MERN stack, which consists of MongoDB, Express, and Node.js, as well as the user interface for React. All of these components work together to serve the final view that the user will see. Express provides the backend framework for the server. It serves content in Node.js, which sends it to the actual web server that's hosting the website. The Google Maps API is where we will get our data for the maps and location directly. The user interface is built by React, which the users can interact with that component directly to update their view of the website and the content that they're seeing. MongoDB will be the database that will serve resources to the users, as well as store the resources that users modify or change. We also have two different views, user account views and the standard user view. The standard user views is just users who have no account, whereas users with an account will have different views depending on their account permissions, which are stored in the MongoDB database. And now I'll pass you on to Kathleen.
Thanks, Ben. I'm going to discuss a couple of our key user stories and our product backlog. The filter resources user story represents the core functionality of our project. This user story describes the main purpose of our application to provide homeless individuals with easily accessible information about resources that are relevant to them. The print resources story describes the need of homeless individuals who do not have Wi-Fi enabled cell phones. We will implement these user stories during our first few sprints. We also have a set of user stories from social workers or resource coordinators who are interested in making accounts, adding new resources to the database, and managing existing resources. Representatives from service providers can also make accounts, allowing them to add information about the specific resource that they provide. Our application will also include a filterable map that allows homeless users to quickly see resources near their current location and get directions to those resources. These two user stories encapsulate the map's key functionality and benefit for homeless users. When developing our product backlog, we prioritized our user stories and assigned them story point estimates through Planning Poker. For items at the top of the backlog, we broke the user story into subtasks and assigned a task owner and an estimate of the hours each task would take. The highest priority item in our backlog is the filter resources user story, which we will implement during Sprint 1. During our Planning Poker meeting, we gave this story a large estimate of 21 story points because it encapsulates the knowledge acquisition stage of development and the creation of the main pages in our UI, in addition to the filter functionality. As you can see, we broke this user story into smaller tasks to prepare for the sprint and estimated the number of hours each task would take. The first task is knowledge acquisition, and we estimate that will take each of us about 20 hours to complete. The next tasks are to sketch the UI design and code the UI, and we estimate these will take about 5 and 8 hours respectively. Next, we'll create the filter component. We estimate that will take about 10 hours. In this stage, we'll also design the database, which we estimate will take 10 hours. And we'll also implement part of the search functionality. We estimate that will take 5 hours. And lastly, we're going to build some of the data view React components. We estimate that will take 6 hours. In total, we estimate we will spend about 124 hours completing these tasks during Sprint 1. Although this is 4 hours over our estimated capacity of 30 hours per person, we expect that some team members will need less time for knowledge acquisition than others. These individuals will take on some of the longer tasks in the sprint. In addition, team members whose total hours are less than 30 will be able to support other tasks once theirs are finished. We also performed a task breakdown for other high priority tasks in our backlog, and we plan to implement in the near future. These tasks are outlined above with assigned owners in our estimates. These include printing resources, providing resource coordinator account access, and allowing coordinators to add resources. We will likely implement most or all of these stories during Sprint 2. During planning poker, we assigned 3 story points to printing resources because this will be fairly simple to complete after the UI skeleton is built in Sprint 1. We then assigned 13 story points to the request access to become a resource coordinator story because this is the first time we'll be dealing with account access. And lastly, we assigned 5 story points to the adding resources story. In this slide, you can see user stories that are further down in our project backlog. We haven't broken these into subtasks because we don't expect to complete them in the next few sprints. You can see the user stories describing the map functionality as well as user stories for other types of user groups, such as service provider representatives. The next highest priority items after those for Sprint 2 involve creating the map and making it filterable. During planning poker, we gave both of these user stories 8 story points each, since we will need to learn to use the Google Maps API to complete them. We gave the next user story, creating clickable pins for the map, 3 story points, since we expect this will be fairly simple once the map is in place. And now I'll turn it over to Thor, who will discuss the technologies we plan to use.
Thank you, Kathleen. Hi, my name is Thor, and just to briefly go over the technologies for the project. The website itself will be architectured with a mixture of React, Node, Express, MongoDB, as Ben mentioned earlier, as well as Google Maps platform. This is sort of the actual foundation for the actual product going forward. In addition, we're also using some technologies to ease development and to test issues. Notably Node.js, because we're working in a JavaScript environment, we'll be running and managing all this. ESLint helps both with code style and also does some minor error detection. Circle CI will do automated code testing for the project. GitHub will be our version control. And Yarn is our package manager to make sure all our dependencies and APIs are the correct ones for each project. Some issues we see moving forwards is an issue of fundings with Google Maps API, as that is a paid product. Beyond this, for this small scope and this demo, obviously we don't have that many calls, so then we can use it for the free. But as the product grows, funding would be a problem. In addition, since this is a crowdsourced based project, how to drive user adoption to help grow the project and actually add more resources, as it's sort of more of a grassroots style project. The next steps we have are our knowledge acquisition for each of us, the actual first parts of Sprint 1, talking to and recruiting volunteers to actually provide information, and develop an initial list of resources to actually demo and produce some sort of functioning product.
And that's all we have for you. We hope you enjoyed our presentation on the Homeless Helper.